Ever wondered if asteroid mining is possible? Is it real? Are there really useful minerals and stuff that we could gather from asteroids? And are asteroids big enough, common enough to be able to do that to the point where it's consistent and reliable resource for us? Could it be the key to unlimited resources available on Earth? In today's video, we're going to find that out. It was recommended by one of our new subscribers. I'll put his name on the screen here. If you like this type of content, make sure you comment, like, subscribe. Let me know if you have other suggestions like this too. Let's get into the video.
Casually watching a video on YouTube on a computer more powerful than anything humanity could build a few decades ago.
Isn't that insane how rapid the progress has been?
This progress and all the wonderful machines you take for granted are built on a few rare and precious materials with names like Terbium, Neodymium, or Tantalum. Getting these rare materials from the ground into your devices is ugly. The mining industry is responsible for air and water pollution and the destruction of entire landscapes. Dangerous chemicals like cyanide, sulfuric acid, or chlorine are used to extract the resources, harming biodiversity, workers, and locals.
It's a very destructive process. Jeez.
And rare resources are also...
And not just destructive in terms of the environment, but also in the communities. In fact, even cause of very high instability in governments in areas that have constant overthrows, warlords, so on and so forth, because of these resources.
Political tools when countries restrict access to them to get their way. But what if we could replace the mining industry on Earth with a clean process that can't harm anyone?
Now that would be a deal.
Well, we can. All we need to do is look up.
Dun, 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 dun.
Asteroids are millions of trillions of tons of rocks, metals, and ice left.
So there's a high frequency of asteroids between Mars and Saturn and Jupiter in that space. So first we need to, master getting there and back efficiently. But I think it's possible to build AI systems and robotics that could go there, do the mining, all automated, and come back with the goods.
Leftovers from the cloud that became the planet 4.5 billion years ago. They can be as small as a meter or protoplanets the size of entire countries. Most of them are concentrated in the asteroid belt and the Kuiper belt, while hundreds of thousands more do their own thing between them.
Okay, so there's even a lot more going on outside the outer belt. But the inner belt here would be much easier to go and come back from, obviously because of the distance. But I wonder obviously this probably has much more resources, the outer belt.
Planets. As space travel is becoming more feasible, scientists and economists have begun looking at the resources found in these asteroids. Even relatively small metallic asteroids may contain trillions worth of industrial and precious metals like platinum.
Wow. I mean, if you bring back that much metals, doesn't that just completely drive the price of that metal to zero?
And bigger asteroids.
But that would probably have a spillover effect into everything from your electronics to, maybe more stability in certain regions of the world.
Asteroids like 16 Psyche could contain enough iron nickel to cover the world's metal needs for millions of years.
Wow.
At current market prices,
and that's just one asteroid.
The rare raw materials alone would be worth quadrillions of dollars. Well, not really, but technically. For example, there are more than 20 million tons of gold in the ocean's water, worth roughly $750 trillion US.
Wow, did you guys know that? Did you know that there was 20, did he say trillion?
But filtering out the gold would be so expensive.
Or did he say 20 million tons? Hold up.
For example, there are more than 20 million tons of gold in the ocean's
20 million tons. Listening comprehension.
Water, worth roughly $750 trillion US. But filtering out the gold would be so expensive that you'd lose money selling it. Right now, asteroid mining has exactly this problem. It's too expensive to replace mining on Earth. Billions of dollars worth of valuable resources in space are worthless if it costs trillions to get them. What makes it so hard? The principles behind mining an asteroid are simple.
The fuel to get there. The equipment. I mean, you could break it, my theory, a way to make it cheaper, maybe break it up into stages. Because getting equipment to hold that kind of material that heavy into space is very hard from Earth's gravity. So maybe have a staging area in orbit already where you could just build piece by piece like the International Space Station. And from the staging area, have ships take off from there to go do their missions and come back. And then at the staging area, bring it down to Earth.
The basic idea is to choose an asteroid, move it to a place where it's easy to process, and then take it apart to turn into useful products. Unfortunately, all of this collides with fundamental problems humans have yet to solve. Going to space is expensive. It costs thousands of dollars in rocket fuel for each kilogram just to reach a low Earth orbit.
Each kilogram.
Going further out into deep space costs thousands more. We need cheaper space travel to make asteroid mining profitable. One solution is to switch from classical rockets to electric spaceships. We already use electrical rocket engines for many of the space probes on science missions. In principle, we only need to build bigger ones. While electrical engines are not powerful enough to fly to space, they require only a tiny amount of fuel to go very far once they're in space.
There we go. So, staging.
This means we don't need to spend a lot of money on fuel, only to transport fuel into space. This doesn't solve the whole cost problem, but it makes it easier to start our first mission. Now that we have an electric asteroid mining spaceship, we need to find the right asteroid and get it there. We've already successfully visited asteroids with space probes and even collected samples. Still, to make it easier and cheaper, our first targets will probably be near-Earth asteroids. Asteroids that orbit, well, near Earth.
Okay, so not even going to the inner belt. Okay.
After a few months of travel, our spaceship finally arrives at our asteroid. Weirdly formed, littered with small impact craters, it hasn't changed much for billions of years. The first thing that needs to be done is to secure the asteroid and stop it from spinning. There are multiple ways to do this, like vaporizing material with a laser or stopping the rotation with thrusters. Once we have a stable asteroid, we need to wait. Orbital mechanics are complicated, but if you push something in the right direction at exactly the right moment, you can move very big things with very little force.
Wow. Okay. Very interesting. So, I mean, this process is going to be very long and slow.
So, we wait for exactly the right moment. Our ship fires its thrusters and nudges the asteroid into a trajectory that takes it near our moon. The moon is useful because
This seems kind of dangerous too. I mean, if the calculations go off, maybe something that hasn't been accounted for. What if we end up sending an asteroid barreling towards Earth,
can borrow its gravitational pull to put the asteroid in a stable orbit around Earth, which saves even more fuel. Again, the trip takes months. But all the time since our ship was launched has not been wasted. The first space mining and processing equipment has been installed in orbit and is now carefully moving towards the asteroid.
So their idea is actually to bring the asteroid close to you before starting the processing part. In my vision, my idea, I'm just pulling it out of thin air, would have been to do the processing right there. But it makes sense to bring it closer, then, reduces all the trips back and forth. But it adds an element of danger of putting something this massive near Earth orbit. I guess he's specified something that's already near Earth orbit, but now we're talking about as close as the moon. Sounds very dangerous.
The processor works very differently than on Earth. Giant mirrors focus sunlight and heat up asteroid rock to boil out the gases. Grinders.
Wow. Wow, interesting. Boil out the gases using mirrors to mine. This is my first time ever hearing something like that. Let me know if you guys came across something like this before.
Break up the dried rocks into gravel and dust, and centrifuges separate dense from light elements. Even if we only extract 0.01% of the asteroid's mass in precious metals, this is still several times more than you'd get from the same amount of ore on the ground. But what now? How do we get our precious metals safely back to ground?
Just launch them. Back to Earth.
There are a few ways, like loading it into reusable rockets that return to Earth from space. Or if our processor contains 3D printers, we can print a faster and cheaper delivery system. Heat-shielded capsules filled with gas bubbles. These can just be dropped into the oceans where ships tow them away. This could be the starting point of humanity's...
Imagine capsules just raining down from the sky, you know. Imagine some landing where they're not supposed to land, you know, like in a city.
First real steps towards colonizing the solar system. As our infrastructure and experience grows, our missions get more and more sophisticated. Parts and fuel produced on asteroids don't have to be launched from Earth at all. The first mining operation makes the second one easier, and so on. While the space industry grows and
it builds on itself,
precious materials become cheaper, eventually we could stop mining on Earth. Even the idea of toxic mining down here might become something weird and anachronistic, like having
probably get banned.
An open fire in your living room. Landscapes ravaged by pollution will heal, while the technological wonders we're used to get cheaper and less toxic to make.
I wonder also the introduction of all these new metals at such high concentration, would they have any other unforeseen consequences on the environment?
None of this is science fiction. We don't need fancy materials or new physics to make asteroid mining happen.
I like that.
We could start building this future today. All we need is an initial push.
Wow. So that's the end of the video. But how's this sound? Is this a business you might want to get into? Because, you know, we're early enough. But hey, apparently we have all the tools to do this right now. It's just that it's a bit expensive, but there's ways to reduce those costs. I wonder if Elon Musk is going to get on this with SpaceX after he's done colonizing Mars. But what are your thoughts on this? Do you think it's very dangerous and irresponsible to bring huge asteroids to start orbiting as close as the moon? Do you think that's a bad idea? Or do you think you feel like all the variables are controlled enough that nothing is likely to, like the chances of anything going wrong would be very slim? Let me know in the comments. If you also have any other videos that you want me to go check out, make sure you comment below, like and subscribe, and share with 5 friends. Thanks for watching. Take care. See you in the next one.